5 times 4 is equal to what? 20. We call these two here, we call them factors. This is a factor. That's called a factor. And the answer is called the product. Just some names, terminology. That's what we call them. And just like the rules for addition, we have few rules for multiplication. The first rule, again, just like the other one's called the identity property of multiplication. And what is that identity property of multiplication? It says if you take a number and multiply it by 1, what is the answer? Same number. Any number times 1 does not change. It's just the number. Or 1 times any number does not change the number. It's always the number. That's called the identity property of multiplications. So what is 5 times 1? 5. What's 1 times 7? 7. What's 2 times 1? 2. What's 4 times 1? 4. So any number times 1 is the number itself. That's called the identity property of multiplication. You have a few of them here. I'll just go through them, list them, then we'll start doing some application with them. We have another rule. I'll leave this up there. The multiplication property of 0. What does that mean? Any number times 0 is what? 0. Any number times 0, the answer is 0. 0 times any number, the answer is 0. That's called the multiplication property of 0. And well, what's 3 times 0? 0. What's 0 times 5? 0. What's 4 times 0? What's 0 times 50? 0. Nothing new. Now, remember the ABA and the CPA? We're going to do the same thing for multiplication. The commutative property of multiplication. A lot of writing here. The commutative property of multiplications. If you remember what I said about the commutative, CPA. CPA stands for what? Change position, right? So what this rule says, if you're multiplying two numbers, A times B, doesn't matter which number you write first. The answer doesn't change. If you flip-flop them, change the position of them, does not change. I call that CPM, commutative property of multiplication. Change position, but you have multiplication now. So if you have 2 times 3, that's the same as 3 times 2. If I have x times 2, that's the same as what? 2 times x. This is important to us because down the road, we drop the dot and we write that what? Just 2x. If you don't see an operation between them, it's always assumed to be multiplications. So that's 2x. So you'll see me take x times 2 and write 2x. Why? Because I'm applying that rule. Y times 3, I can write that as what? 3 times y, which is 3y, right? So if you flip-flop them, it's not going to change anything. Two more properties here. I'll slide it up so you can catch up. We keep you going here. No break. By the time you go home, your finger's going to be sore. The associative property of multiplications. The associative property of multiplications. Again, associative property. Adjust the parentheses. APM we call that because that's a multiplication here. If you're multiplying 3 numbers, the order does not change in this rule. You can multiply the first 2, get an answer multiplied by the third one, or you can multiply the last 2 first, get a number that multiplied by the first one. 2 times 3 times 4. You want to multiply these numbers. Doesn't matter which 2 you multiply first. So on the left side, I'll multiply the first 2 first. What's 2 times 3? Good. What's 6 times 4? 24. Let's see if we get 24 on the other side if I multiply the last 2 first. What's 3 times 4? 12. 12 times 2, which is what? 24. So that's the associative property of multiplications. And the last property here is the distributive property. Which says if you have, for example, A times, you want to multiply B plus C, you can distribute that. You can multiply the A times the B plus, that sign doesn't change, A times C. The real name for this, the distributive property of multiplication with respect to addition, but our book doesn't talk about it, just go distributive property. So if I have 2 times 4 plus 3, I have an option of doing this. I can distribute that. I can multiply 2 times 4 plus 2 times 3. I can either do it this way or do it that way. If I do it this way, I got to do what's inside the parentheses first. What is 4 plus 3? 7. What's 2 times 7? 14. If I do them the other way, you'll see soon enough, we got to do the multiplication before the addition. 2 times 4, 8. There's the plus sign. What's 2 times 3? What's 8 plus 6? Is it 14 again? It's the same answer. Now, why did I multiply first before I add them? There's a rule, it's called order of operations, PEMDAS, coming up later in the course. You got to do the multiplication before you can do the additions. Some of you probably remember, please excuse my dear Aunt Sally. You know, that's what that is, the rules. Which one we do first. So how do we multiply numbers? And where do we multiply them? An example. I'm sick and tired of this weather. My wife complains every day. She hates this weather. So let's say, I don't have it, but let's say I decide, you know what, let's go to Florida for spring break. I'm tired of this weather. And my daughter will be home. She'll be on spring break from school. So let's say I go online and I find a flight for $312 to go from Springfield to Orlando, round trip. And I want to buy 3 tickets. That's with taxes. And I want to buy 3 tickets. How much is it going to cost me to purchase that? We go 312 times 3. 3 times 2, 6. 3 times 1, 3. 3 times 3, 9. $936 to get the 3 tickets. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Another example. There's 15 students in the class today, and let's say there's a show downtown Springfield. The tickets for it is $32 a person. And we decided all 15 of us going to go watch that show, something about math, fun stuff. We're going to go see this magician. It's going to make you love math. Hypnotize all of you. And when you hear math, you're going to be like, oh, this is the best thing there is, like eating steak. Unless you don't like meat. So how much is it going to cost us to buy these tickets? I got to multiply them. 5 times 2. 0, carry 1. 5 times 3. 15 and 1. Now notice the 1. 1 times 2 is going to go right here. 1 times 3. 0, 8, 4. It's going to run us $480 to take the entire class to see this hypnotism. Or maybe you're doing a remodeling job at home. You decide the carpet in the bedroom, been there for 15 years, ugly, and Lowe's, someone said Lowe's early, Lowe's is having a discount this week on sale. They have a carpet free installation. I just heard their commercial. Actually, I don't know, Lowe's or Home Depot, one of them. So you can buy the carpet, installation is free. Good time to buy a carpet. So you measure the room, and the room is 4 yards. That means 12 feet. 4 yards by 5 yards. You got a big room here. So the area of that room, the carpet here, is going to be area of a shape like this. That's called rectangular shape. It's the length times the width. You go 4 times 5, which is what? You need 20 square yards. A lot of times when you go to Lowe's, you'll see it written SQYD. In case you're wondering, what does that mean? Square yards. If you buy these pieces, a yard by yard, and you attach them, you need 20 of them. And now, let's say the carpet happens to be, what's the price of a carpet per square yard? Let's say $28 a yard. They're not cheap. So how much is it going to cost you? It's going to be $28 for each yard, and you have how many yards? 20. You're going to multiply these numbers. What's 28 times 20? 0 times 8. 0 times 2. 2 times 8. 6 carry 1. 2 times 2 and 1. So that room, that bedroom is going to cost you $560 to carpet that room. Again, sometimes you want to estimate how much. You know, you're multiplying big numbers. Let's see, want to estimate 328 times 179. Estimate. I'm not looking for the exact answer. So what I'm going to do is round these numbers. Maybe I round them to nearest 100. To nearest 100, what's that number? 300. Because that's the 100 location. Is that 5 or more? No, don't change that number and make these zeros. Times, there's the 100. Is that 5 or more? 200. So quickly, 300 times 200. Now I'll mention the shortcut shortly for those people wondering. 0 times 0, 0, 0 times 0, 0, 0 times 3, which is what? How about 0? Right? Yeah. Someone says 6 there. 0 times 0, 0, 0 times 0, 0, 0 times 3, 0. 2 times 0. 0, 2 times 0, 0, 2 times 3, which is 6. 0, 0, 0, 0, 6. Going to be 60,000. By the way, some people get the answer quickly. There is a shortcut to a problem like this. Yep, you see the zeros here? There's 2 zeros and 2 zeros. Don't even pay attention to them. What's 2 times 3? And how many zeros combine between these two numbers? 4 zeros. So when you're multiplying numbers like these, we can cheat and use that shortcut. Just like if I have 120 times 30. I know there's a 0 here. Let's say times even 300. How many zeros altogether do I have? 3. So my answer is going to have 3 zeros in it. What's 3 times 12? So that's the shortcut. You multiply the numbers without the 0. 3 times 12. 3 times 2 is 6. 3 times 1 is 3. That's 36. And you add the 3 zeros.